Alright, let's continue with, oops, sorry. What am I doing? Alright, get the right tool here. Excuse me. Alright, let's continue with chapter 8, the retake. So it says, I guess we're on number 15 now. It says, find the angle of elevation of the sun if a building is 125 feet tall, cast a shadow of 196. Okay, these building shadow ones are pretty easy if you understand what's going on. So here's your building right here, and your shadow is cast along the ground. Be something like that. Let's see, 125-foot building, 196-foot shadow, probably around something like that. Doesn't have to be exactly to scale. So that's close enough. And it makes a right angle. We make an assumption that the building is perpendicular to the ground. And it says find the angle of elevation of the sun if a building is 125, so that's 125. And the shadow is 196, and we want to find the angle of elevation. Well, the angle of elevation is from the horizontal up, so that is the elevation of the sun. See, the sun is up here, shining down, casting a shadow along the ground. Here's the building, and the building has cast a shadow along the ground. This is the angle of elevation from the sun, or to the sun. It's from the horizontal up, and that's what we're trying to solve for right there. Trying to solve for that angle, because that's what they ask for, I believe. Let's double check. Yep. It says find the angle of elevation. Alright, let's go ahead and do that. Well, we can use trig function since we have a right triangle, and so we go opposite over adjacent, and that is the tangent. So we take the tangent of theta is equal to opposite 125 over the adjacent 196. Now we have to solve for the angle. Remember, when we solve for the angle, that's when we do that inverse. So we get rid of the tangent, not by dividing, we get it by taking the inverse. So we take the inverse tangent of this, it goes away, so we've got theta equals, and then we take the inverse tangent of the other side. This is our little designation, our little notation for inverse tangent of 125 over 196. Alright, let's put that into the calculator. So here's the calculator right here, and so I'm going to go inverse tangent of 125 over 196, or divided by, and then hit that, and it's about 32.5 degrees. So angle theta is 35. Well, it says round to the nearest degree, didn't it? So it says 0.2. We'll just keep it 35. So that's approximately 35 degrees, and that is the answer for, almost there, 15 right there. That's it. Alright, let's look at the next one. Alright, let's check this one out. This one's got a little bit of higher degree of difficulty, I guess, if you want to say that. Let's draw the picture. Let's see what's going on here. And we've got a right triangle. Alright, it's always nice. Like this, like that. And we've got another line in here. So I'm doing it without all the pretty picture of the sun and the palm tree and all that. We're just actually just putting the numbers in and seeing what we get. That's 76, that length is 18, and this little tiny skinny angle is 4 degrees. And we are trying to find the length of the tree to the nearest tenth of a foot. So let's come back up here. Let's make this a little bit bigger so I can see it. Alright, and we're trying to find the length of the tree. This is the tree right here. Remember, it was leaning, so we'll call this just X. Is that alright? I'll tell you what, let's do that in a different color just so it stands out a little bit. Alright, so that's X. Right, and they also tell you that you've got a right angle right here. Alright, well, let's see what we're going to do. We're trying to find that length right there. Let's make that the same color as X. There we go. Now it stands out a little bit. That's what we're trying to solve for. So, let's see what we can do. Here's a side. I know the angle opposite that side, which is 76. That's nice. So what am I thinking? I'm thinking a non-right triangle, right? Because this goes through that right angle right there. So we don't have a right angle anymore in this triangle right here. So I'm thinking, okay, non-right triangle. I got a side. I got an angle opposite the side. I know another side. It'd be really nice if I knew this angle right here. If I actually knew that angle, I could use law of sines and solve for X. Well, I might be able to solve for that angle, so let's take a look. Where does this 4 degrees come in? It's this little skinny angle right here, but it's part of this 90, so if this is 4, then what's the rest of this? That's right, it's 86 degrees. So if that's 86 degrees, I should be able to find this angle up top here. And that's easy because it's just the difference of these and 180. So it's 180. Let's see, minus 76 minus 86. Let's see what that gives us. I already did it earlier. 180 minus 76 minus 86 is 18 degrees. So this little angle right here, I know it doesn't look to scale, but that's okay. That's 18 degrees. So now I should be able to use a law of sines. So if I'm going to try to solve for x, watch, I'm going to go x over the sine of 76 equals, and then I got to do the side and the angle. So I've got 18, that's the length of the side, and it just so happens that the angle opposite is also 18. There's really no significance to that, but it's over the sine of 18 degrees. And now I can solve for x. The reason I put x on the top is because it's a lot easier. Okay, we've talked about that on several different occasions. It's a lot easier to solve for x if it's already on the top. So I purposely, when I set this up with the law of sines, I purposely put what I'm trying to solve for up on the top. Now let's get rid of the sine of 76. We do that by multiplying by the sine of 76. And now I'm just going to plug all that stuff into my calculator and see what I get. Let's turn it on. Okay, so I've got 18 sine of 76, 18 sine of 76, and then divide that whole thing, I think you can just hit divide by the sine of 18, sine of 18. And that gives you about 56.5. So x is 56.5, and that's exactly what we're trying to find. We're trying to find the length of that tree that's leaning over, which is that yellow one right there, and we just did it, and it's 56.5, approximately 56.5. Alright, I don't have my answer key in front of me. I think I left it at school because I'm at home in my basement talking to myself, it seems like, but hopefully somebody out there in the internet world is listening to me. Okay, here we go. Number 17, before I really start talking to myself. In triangle ABC, they give you a whole bunch of stuff here. Okay, let's draw this. We're drawing a triangle. Let's just take a look at some of my angles inside the triangle ABC. One angle is 46 and the other one is 105. The 105, it doesn't have to be drawn exactly to scale, but it is kind of nice to know that you do have an obtuse angle. So it would be nice to really draw our triangle so at least we have an obtuse angle. It may not be exactly 105 and it looks like it's quite a bit larger than 105, but that's okay. At least we got an obtuse angle here. So if this is my 105 degrees, if that's my obtuse angle, I'll call that B. And then it's triangle ABC, so I'll call that A, B, and C. Well, A was 46, so let's make that 46 as well. I could have gone this one. I could have gone A, then B, then C. Doesn't make any difference. What else do they tell you, though? They tell you the two angles, which you've already got marked right here, and they tell you little c. What is little c? That means the side opposite angle C. Well, I don't even know angle C, but that's okay. I know the side opposite, though, is this one right here. So this side right here would be 19.8. So that's 19.8. So I do know that side right there. And what are we trying to find? We're trying to find little a. Well, little a is opposite angle A. So here's angle A right here. This one right here is little a. And that is what I'm trying to solve for. So now I don't need the test anymore. We can look at this and figure out what we're going to do. Well, law of cosines probably would not be the best thing here. Let's go to law of sines. Just like we did on that other word problem. Look at this. I know I'm trying to find this right here, and I know the angle opposite that side. Well, I know another, let's see, I know another side, right? And I know another angle, it's true, but there's no way I can find that side right there. But I do know this side. I could find this angle right here. Wouldn't be that hard. Let's do that. It's just 180 minus these two right here. So it's 105 and then 46. So let's do that. I haven't done these previously, so let's just do it all together at the same time. So it's 180 minus 105 minus 46. Let's see, that's 29 degrees. So that angle C right there is 29 degrees. Let's put that in there. All right, let's change colors a little bit. There we go. All right, now this is set up really nice to use law of sines just like we did before. Because if I'm trying to solve for little a right here, I know the angle opposite, and I also know this. I think in one video that I saw, this teacher teaching this, they called it, what they call it, a side angle combination or angle side combination. That means if I have an angle and a side opposite that angle, okay, that's what I need. And here is another angle side combination. It just happens to be I don't know that side, and that's what I'm trying to solve for right there. Okay, so that's perfect for law of sine, so let's do it. Again, I'm trying to solve for a, so that's what I'm going to put on top. Okay, so the a goes on top, and then the angle is 46. The sine always goes with the angle. Don't ever put the sine with one of the sides. Like you would not put the sine of a. It doesn't make any sense. You can only take the sine of an angle. I hope that makes sense. We've talked about that quite a bit. All right, so what do? We did this angle side combination. Let's do this angle side combination. If I put the side up top, I got to put the side up top on the other one as well. So that's going to be 19.8. And then I'm going to put the angle down the bottom. But not just the angle, I got to take the sine of the angle. So it's the sine of 29 degrees. The math is easy. We did a problem just like this before where we do the same exact math. We're trying to get a by itself, so get rid of the sine of 46. So the sine of 46. And then we will plug it into a calculator and see what we get. 19.8 sine of 46 divided by the sine of 29. Hope these work. And that's 29 point, let's say 4. Okay, it is a side, so we'll round it to the nearest tenth. So 29.4. So A equals 29.4. And that's what they ask for. They ask you to solve for the length of side A, the side that's opposite angle A. Okay, we're rolling right along. Number 18 looks kind of like this right here, so let's set it up the same way. Again, let's look at the stuff that they give you. They give me a couple sides this time, and then give me an angle. Well, just like before, we got an obtuse angle, so we're going to have another obtuse triangle. Might as well make it kind of look like the other one. Something like this. And again, it doesn't have to be perfectly to scale, but at least it gives us an idea what this thing really should look like. So I know that this is 108, so I'm going to make that 108, and so angle N goes with the 108, so I'll definitely make sure that that's the N right there. What are my other letters? L, M, N. So I'll put L right here, we'll put M here, and N, so it's L, M, N. Let's see what else they give us. This is lowercase l is 42. So lowercase l, or small l, is opposite angle L, so that's the side, so that's 42. So that length of that side right there goes 42, and it has to go opposite angle L. What else do they give you? They give you little m, which is 61. So little m is side m, and it's opposite big M, that's capital M, which is angle M. So little m would go right here, and that is 61. All right, and we are trying to find n, little n, that's what we're looking for. Little n is opposite angle N, so that right there would be little n. All right, we are set and ready to go. We're not going to use law of sines on this. Even if we wanted to, we couldn't do it, because look, here's an angle side combination, so that means I'm going to have to know one of the other angles. I really can't find one of these angles in this situation right here. So like if I knew this angle, if they told me that angle L, and I know the opposite side is 42, yeah, I could use that angle side combination with this one to solve for N. If I knew angle M, because it's opposite 61, if I knew it, that combination right there, yeah, I could use that to solve for N, but I don't know any of those. So what I'm going to do, this is side, angle, side situation. So whenever you have either side, 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 or side, angle, side, that's a good time to use the law of cosines. All right, we can't just use a regular trig function like sine, cosine, and tangent. We have to use the law of cosines on this. So let's set it up with the law of cosines. This is the side that's opposite this angle. So this is kind of like our C. Remember our law of cosines, C squared equals A squared plus B squared minus 2AB cosine C. So this is kind of like our little C. So I'm going to go N squared equals. Now it's these two sides squared and added up. The sum of those two sides, 61 squared plus 42 squared minus 2 A times B, or these two numbers right here, 61, 42. The cosine times the cosine of angle C, or in this case, it's not C, what is it? It's the angle that's opposite this side that we're trying to solve for. So it's 108 degrees, so it's the cosine of 108 degrees. So really, there's nothing tricky about this. It's basically just putting this into a calculator. Now, I did give you a big hint. Hopefully you guys remember right here, okay, when I subtract, I got to subtract all this stuff right here. So I think it's very helpful to put that into your calculator. And let's see what we get. Let's see, I'm going to have to move some things around. Let's move that a little bit closer that way. Now let's see if I can fit my calculator in. Sure enough. Alright, let's turn it on. Let's clear the calculator and let's put some stuff in here. 61 squared. 61 squared plus 42 squared. 42 squared minus, now big parentheses, that's why I put that. So put a parentheses and then 2 times 61 times 42 cosine of 108. Cosine of 108. Now watch, oops, it's not 118, it's 108. Good. Now look what I did. I put a parentheses right here just to close in that 108. It's not really shown here, but on the calculator it puts up a parentheses here, so I need to close that one. Then I need one more to close this parentheses right here, so I'll put another parentheses. All right, equals. Now that's not my answer though. 7,000. Okay, do you think at all that that thing's going to be 7,000 and something? So don't just be so quick just to put something in your calculator and then write down the first thing that pops up in the calculator. You got to understand n squared equals all that stuff. So what do I do with that? I take the square root of it. So take the square root of that answer right there, and that's going to be about 84. Now does that make sense? Does 84 make sense? Yes, it absolutely does. So n is about 84. Was there a decimal? Let me see. 0.1. We'll say 0.1. Okay. So n is 84.1. Does that make sense? Yeah, it's the biggest side. It's opposite the obtuse angle. The obtuse angle has to be the biggest angle. So absolutely it makes sense, and it actually looks to scale and everything according to all this stuff. Okay. Now look, this doesn't look to scale because look, I made this 61. That looks way shorter than the 42, but it's fine. It's no big deal. It still works out. The math all still works out perfectly fine. So that is your answer to that one right there. All right, here we go. We're going to do these together right here because they all fit to be the same one. This is vector. We didn't do a whole lot of this stuff before, so it's been a while since we've done this, so you may want to look at this pretty carefully. So let's find the magnitude of the vector. That's actually a pretty easy part, but you really don't even need to draw this to find the magnitude, but we're going to, just so that you have an idea inside your head what's really going on here and what are we doing. So it says find the magnitude of the vector. So the vector, it starts at W and it goes to Z. So let's put in W. It's negative 2, 2. So I'm not going to be real picky about making sure this is perfect, but at least it gives us a guideline. So that's W right there, and that's at the point negative 2, 2. Let's plot the other one, 3, 1. So 1, 2, 3, and then 1 would be about right there. That's Z. Mark that as Z. And that point is 3, 1. Okay, so what we're going to do, let's make this a different color now. What we're going to do is draw the vector. The vector has a beginning, and I shouldn't say it has an end, but it does have a beginning place, and it goes through another point. So where does this vector start? It's called vector WZ, so it starts at W. And this is pretty important, and it goes through Z right there. And we put an arrow there because it does have a direction. Vectors have a direction. They have a magnitude and a direction, so the arrow indicates the direction that it's going. So what we have to do is find the magnitude. The magnitude just means how long the line is, basically. So look, I've got 2 points, and I should be able to find the length of that line. And we have a way of finding the length of a line, or a line segment. And that's the distance formula, especially if they give you 2 points. So here's the distance formula. Remind you, we used it quite a bit at one point in the book. It's been a while since we've used it, so you might want to review this a little bit. So it's basically Pythagorean theorem. Really, if you wanted to, you could drop this down, take this across like this, make a right triangle, and you can see that it's going to be Pythagorean theorem anyway. But if you have the distance formula memorized, we did quite a bit of this at one point. This makes it a little easier. So what do? Subtract the x's from each other. So it's negative 2 minus 3, and subtract the y's from each other. That's 2 minus 1. Negative 2 minus 3 is negative 5 squared is 25, plus 2 minus 1 is 1, squared is 1, so it's just the square root of 26. You don't even need a decimal for that. Just keep it the square root of 26. That's the magnitude right here. So I would just put the square root of 26, and that's your magnitude of the vector. All right, hope that makes sense. Now we got to find the direction. The direction is always the part that's a little bit trickier. So I'm going to go a different color here. We'll go with this nice pink. And let's find the direction. So what we want to do, it starts here and it goes down in this direction. So what I'm going to do is I'm going to draw a little x and y axis and put the starting point of that vector right at the origin of my new little x and y axis. I might have to drop that a little bit. That's pretty good. Okay, so that purple right there is my new x and y axis. What I'm trying to do here is I'm trying to, actually, oops, just changing the color of this. What I'm going to try to do is make a right triangle out of this. So I go to the end, they call this the terminal point, I guess, or something, but I just say it's the end of the vector, and you just take this up to the x-axis. So you make a nice little right triangle out of that. See that right triangle? So what I want to do is I want to find this angle. That angle is my direction. Technically, when we write the answer, though, the angle is going to start here and it's going to go all the way over. But I need to know that little skinny angle right there. That's pretty important. We'll get to that later. So here's my right triangle. If you really wanted to, because it's kind of messy in there at this point, if you wanted to, you could always just do this. Just kind of draw it a little bit bigger, just so you can work with a little bit bigger, better, and it just looks a little nicer. So that's a right angle. You're trying to solve for that. And what do we know? Well, yeah, we do know the length of it. It's the square root of 26, but let's just put these two sides in. How do we get that length? How do we get that length from here to here? Well, where did we start? We started at -2, and we ended up over here at 3. So what's the distance from here? You could just count if you wanted to, 1, 2, 3, 4, 5, or you could just subtract these x values. Either way you do it, doesn't make any difference. So the length of that is 5, so the length of that is 5. Hopefully that makes sense. I'll put it here too if that doesn't bother you. So that length right there is 5. What about this up and down length? Well, let's see. We started here at 2 and we just dropped down to a 1, so from 2, right, on the y, see, there's 2 and then there's a 1. So 2 to 1, how far is that? It's just 1, so that's a 1 right there. And what are we trying to do? We're trying to solve for this angle, right? Now we're going to use that angle. It's not going to be our final answer, but we're going to use that angle. So let's solve for that angle, though. So it's going to be the tangent. How do I know it's tangent? Because it's opposite over adjacent. So it's the tangent of the angle equals the opposite over the adjacent. Take the inverse of the tangent, so it's the tangent inverse, or inverse tangent. That's supposed to be a 5. That was pretty ugly. Let's try that one more time. There we go. Looks a little better. Alright, and then we put that into our calculator. I think I already did it. Let's do it again. I know it's there, but let's do it live in person. Okay, so we take the inverse tangent, so second function tangent of 1 over 5. 1 divided by 5. And that gives you about 11.3. So this angle right here, so theta, oops, I'm off the recording part, let's do it right here. Theta is about 11.3. It's approximately 11.3. It's not my final direction. My final direction, and let's do this in a different color, let's go yellow. My final direction, remember it starts at the positive x-axis and it has to go counterclockwise. That's the direction that we go. So that right there is what we want to find. But if you take a look at this, see this little skinny angle? That's 11.3. So how do I find this big yellow one? Look, if I went all the way around to here, that would be 360 degrees. So I just take 360, take away 11.3, and then that's your answer. All right? I should be able to just do that in my head, but I'm going to do it here anyway. 360 minus 11.3. And that gives you 348.7. 348.7 degrees. That is my direction because it's from the positive x-axis counterclockwise until you hit your vector. That's the angle that we want to find. Well, we found this angle inside the triangle because it was easy to do our trig function. So all I do is take this little bit right here. See that angle? I just take that angle away from 360, right? Because if I went all the way around, that would be 360. Take that away from it, and I've got 348.7, and that is the direction of the vector. All right, that's chapter 8. Hope you enjoyed it, and I think I might just teach the rest of it in class tomorrow. Well, so, see you tomorrow. Bye.